Good afternoon, everybody. I'd like to thank you for joining our webinar, and I'm very happy and excited because today we will show you new things which has been developed and prepared for our users. But before we start, I would like to introduce us to you. My name is Marcin Delecki, and I'm a product manager in the CloudFerro. Today with me, I have three guests. Bastian Berlin, GIS system administrator from Jordbruksverket from the Swedish Board of Agriculture. Along with me, I have two colleagues of mine, Jędrzej Bojanowski, PhD, Deputy Head of Remote Sensing Center from Institute of Geodesy and Cartography in Warsaw, and also Jan Musiał, PhD Assistant Professor at the Remote Sensing Center Institute of Geodesy and Cartography. Before we start, a few words about the upcoming agenda. First of all, I will give you a full scope of reasons why you should choose the Sen4CAP as a service in the CREODIAS. Then Bastian, Jan, and Jędrzej will share use case of their work with Sen4CAP on a daily basis and their experience of the software. After that, a few words about upcoming upgrades and new services related to the agricultural sector and, of course, to the Sen4CAP. At the end, we will have a few minutes for a Q&A session. So if you have any questions during the webinar, feel free to write them down in the chat box and we will try to provide answers. If not, we will send all the answers along with the presentation in a couple of days after the presentation. At the beginning, maybe a short reminder about the CloudFerro. CloudFerro has been founded in 2015 and is headed by a group of experts from IT sector with over 20 years of experience. And we have been trusted by big leading European companies and scientific institutions from various big data processing market sector, including the big names, of course, like ESA, European Space Agency, the European Center of Medium Range Weather Forecast, Mercator Ocean, German Aerospace Center, EUMETSAT, and of course many more. We are mainly focused on delivering and operating large cloud computing environments and multi-petabytes scale storage. And what makes us different from the market is our specialization towards processing large data sets of Earth observation data imagery. As you can see on the timeline, we have grown several times over the 6 years, and we have delivered and continue to develop a few major platforms well known in the Earth observation sector, like of course CREODIAS, the Wikio, the CODD for the DLR, but also we provide build and of course maintenance a few hybrid cloud environments located in the offline place. One is the climate data store prepared for the European Center of Medium Range Weather Forecast. Going forward to Sen4CAP, what we developed from first release of the Sen4CAP, we custom-made virtual machine image that include all required components for the Sen4CAP, like atmospheric correction processors, the Maya, the Sen2 core, SQL database, Apache server. Of course, the Sen4CAP is located in the CentOS operating system, along with graphic user interface, and with connectivity to our EO data repository, which includes required data for the Sen4CAP, the Sentinel-1, Sentinel-2, and of course, Landsat 8. This is the first new thing that we've developed, and it has been published a few days ago. We have 4 different virtual machine images. The first one is the default, like the standard that is normally provided by the Sen4CAP with the SRTM data, but there are 3 others, especially, let's say, prepared for the Northern European users, that they can choose between Aster DEMS, UA DEMS, and of course different atmospheric correction processor, the Maya or the Sen4CAP, which is of course available also on the CREODIAS platform. Right away, after the picking up proper version and after the installation of the image that is prepared, we are ready to use, ready to go. You don't need to put any additional configuration to the virtual machine. But of course, if you want to install anything more, or you would like to change anything in the backend, you have full access to the virtual machine. You can connect directly to the Sen4CAP using the website browser, or you can use remote desktop. In this case, this is a VNC protocol client. For instance, you can use always the X2Go. Based on our experience, and this is the second new thing that we prepared, we also create a new business model for offering the Sen4CAP solution. And from now on, you can use the Sen4CAP on CREODIAS with package in which you will gain a few benefits. And what is important, this is very cost effective, because besides the all Sen4CAP and CREODIAS features, you will also gain package of hours with our premium support, and you can exchange the hours in the subscription, in the contract, for a few different things, like technical trainings for paying agency, of if you are classic commercial entity, or of course educational entity. We can prepare technical trainings, the internal webinars. We have always available different experts and data scientists for the consultation, and you can also get this through exchanging of the package from the hours. If you are a very beginner user, we can provide you assistance in getting started from step by step to getting the results in the Sen4CAP. But also, what is important, we prepared 3 levels of different support. So normally, if you are buying, if you are using the CREODIAS environment, normally you have level 1 support, which we provide to our infrastructure. But normally, if you have operating system and anything going on, normally we don't connect, and we can't help on this environment, because this depends on the client. But in the case of Sen4CAP, we provide also the level 2 support, when we can change anything or upgrade anything in the virtual machine, and of course level 3 support, and this is exclusively connected to the any problems regarding the Sen4CAP. So as you can see, every user of the Sen4CAP on CREODIAS will have a very easy way from creation of the virtual machine to getting some results with our support if there is a need. So as a CloudFerro, we guarantee for the user, if he will pick the Sen4CAP on the CREODIAS, that we will have always the latest version of the Sen4CAP day by day. Because we are DS, we will have a new Copernicus data, so you don't need to worry about ingesting the data to the Sen4CAP. You have full support. Whole environment of the CREODIAS is secure and compliant with the GDPR. We have EO data experts and sales support available to you, so we can always schedule a fast call and provide all the information that you need. And last thing that is most important, and I think, that we provide good discounts if you are interested in subscription for a long period. So basically, you will only pay for the virtual machine. We don't charge anything more for the Sen4CAP, because the Sen4CAP is open source. And if you need always increasing amount of storage, we always build the storage per 1 gigabyte. So this is a very flexible solution in the context of Sen4CAP, because from growing season to growing season, there is a demand for more storage. As you can see, we try to develop a solution that is in the same time very easy to use and very well fitted to different types of users. And right now I'm passing the voice to Bastian Berlin from Swedish Board of Agriculture. Hi, Bastian.
Yes, hi, thank you very much. Yes, hello everyone. My name is Bastian Berlin, and as Marcin said, I'm working for the Swedish Board of Agriculture, so the Swedish paying agency. And yeah, today I will show you a little bit how we are using CREODIAS and Sen4CAP system, and also a bit about sort of our results and our experiences with working with these kind of systems, and yeah, sort of preliminary results, since we're still sort of in the season, so not everything is like finally tested. So this will be a short presentation about these kind of things. I'm working as a JS system administrator, and currently mainly working with the setting up of the area monitoring system in Sweden, and working there as a project manager for the part which is mainly focusing on the satellite analysis, so that we have results which we can use for our eligibility conditions, and then see if we can yeah, contact the farmer about the things which don't look as they should in our satellite analysis. Yes, so that's a little bit about myself. So I will jump right in. How does it look currently at the Swedish Board of Agriculture? And we're sort of in a testing phase, but also starting to sort of put systems together, since I mean, the paying agencies need to start using the area monitoring system in 2023. So it's very little time we have to put up the system which works. So it's like, yeah, everyone is hard pressed, you could say. But you could say that this is sort of how it looks currently. We have sort of our internal system here, which is yeah, on our own servers, where we pretty much have all of the rules for the eligibility conditions, and this one is sort of currently starting to put into place. And from there we will sort of connect to the DIAS, where we have also Sen4CAP running currently. And as you all know, there we have the Sentinel-1 and Sentinel-2 repository available. And one part of the Sen4CAP image is that it uses a Maya cloud mask to do the atmospheric correction for the Sentinel-2. And it's also using Snap to create coherence and amplitude data for the Sentinel-1. And then that data is obviously in the DS available for analysis. Then we're doing something special. I don't know if it's only we in Sweden we do it, but we have a major problem with trees in Sweden, especially in our pastures. It's not a problem when it's about legibility. You can have some trees in your pastures, as long as it's not like newly grown trees, but these have like very high environmental value, but it makes it really difficult to sort of get a clean signal in your analysis. So we're using a 10 by 10 meter pixel tree mask over the whole country to sort of filter out trees and shrubs to get sort of a clean signal for the grass. And these kind of polygons we actually putting in the database Sen4CAP is using to then use the different analysis Sen4CAP is offering. And I mean, just by doing this step here, it improved quite heavily our results, since you can imagine that a tree cover sort of equalizes the signal you're expecting and makes it sort of yeah, it doesn't show any effects of the agriculture practices anymore, since it's sort of covering the signal. And then currently we are sort of thinking in two ways here. We have the analysis modules which Sen4CAP is offering, like the crop code classification, the mowing, and the tillage detection. And these are all working fine. There's no problem with it. But we also see that there's still always parcels left which don't get a clear result. And that's mainly because the reality is there's much more going on out there than these three analyses can capture. I mean, if you just think about the grazing, it's really difficult to find that with a mowing detection, because it's different signals. So since the version, I think 2.0 in the Sen4CAP, maybe it was even in 1.3, I'm not sure, we have this markers database as well, which pretty much has all of the time series for NDVI and coherence and amplitude for each parcel. And from there, we can use our own analysis, which we're currently writing in R, to, yeah, pretty much use the data provided here and build our own time series analysis, where we are looking for different kind of signals which are not covered by Sen4CAP. And we've worked a lot on the grazing, since it's one of our main problems in Sweden. It's very difficult to detect, but it's also, if we can solve the grazing well enough, then the other sort of analysis usually are giving really good results with kind of simple analysis, but the grazing, you sort of need to step up your game. So it was really good to sort of have this option to use the data created by Sen4CAP and sort of plug it into our own analysis. Here we're also working with the homogeneity analysis, which is one of the probably mandatory parts for the AMS. And then we can do some other analysis, which are maybe a bit similar to the ones in Sen4CAP, but which treat the signals differently. We're also using some more cloud filtering, where we sort of we're looking at these tree pixels next to the polygons, and when we see a dip in our polygon, but we also see a dip in the tree pixel next to the polygon, it's probably cloud, because it's unlikely that the trees got cut. So then we will not use that data point. And by that, it was really improving our results to sort of take out the pixels where we see like, okay, but we also see a drop in NDVI in the forest next to the polygon. That is unlikely. So it's probably a cloud or a cloud shadow. And from here, we're pretty much taking these results of these events, and then we send it to our internal system where we have the eligibility conditions, and then we see if it's okay what the farmer was applying money for, or if it's not okay. And as I said, like, there's still like nothing here is really done yet, but we're getting there. Yes. Let's take, yeah, this is just some examples. And like if you, for example, take the mowing analysis, and there's a lot of grasslands in Sweden. It's not a surprise, since there's quite a lot of areas which not have the greatest soil conditions. So then what do you grow? You grow grass, and you cut it and you graze it. And this is kind of like a classic mowing analysis, where you sort of look at the change of NDVI over time. And if it's sort of the change is big enough, then you mark it as a mowing event. And this is quite similar to Sen4CAP, but we've also built our own analysis over it, which sort of treats the signal a little bit differently. Yeah, this is just some preliminary results from the mowing analysis, which is actually built into Sen4CAP. So this is not our own. And it was on fallow lands. And I mean, and the fallow lands are a little bit special, since you're not supposed to cut them under a certain amount of time of the year. But to sort of get the basic payments, you still need to do some sort of agriculture activity on them over the time of the season. And this is based on Sentinel 1 and 2. And as you can see, it's roughly half of the parcels which get a mowing result. and half don't. And I mean, this is a bit, yeah, it's not that great because I mean, most of those still had an activity. It's probably because of the clouds and the how the signal behaves over the season that it did not get captured. And it shows a little bit like, yes, Sen4CAP is really great to filter away obvious results. So all of these 50,000 parcels, we can say, okay, they are fine. But then with the rest, we still need to do further analysis because there's still plenty of activities happening here, which Sen4CAP did not find. So it's really good to sort of filter, and then you still probably need to use some of your own analysis to actually get to the ones which did not have any activity, because usually that's only a few % in your total population. But it was really good to see that we could integrate the Sentinel-1 in the Sen4CAP analysis, since we had struggles to sort of get easy access to Sentinel-1 data outside of the Sen4CAP framework. So this was definitely an improvement for us. It's also notable that it's a very slow processor, unfortunately, because right now there's no parallel processing built in. So that's hopefully something which gets improved in the future, because I think it took like a day or 2 days to run this analysis. It's a little bit too slow. Yeah, something about the mowing. Yeah, the grazing is very tricky. We've collected quite a bit of ground truth, detailed ground truth, where some of our field controllers followed parcels over the whole season and sort of marked where, you know, animals got put on the field and when they were taken away, and sort of how many animals and so on. So we could understand a little bit better the variety of signals you could get over a season with different grazing patterns. And that also makes it so difficult to find sort of one analysis which gives you a clear result. Did it get grazed or not? And this is like a really good example. It's a bit small maybe to see, but here in the beginning of the season, the grazing started, and then the animals were pretty much out almost the whole season until the autumn, where they got taken away. And you can see, like, if this is a signal which we would not capture with the sort of mowing analysis, and it looks like it's abandoned, but it's not. Potentially, usually, if it would be abandoned, this NDVI would increase much more. So you could say that the top got grazed away. But it's very difficult to sort of get a clear result. Yeah, this got grazed or not. So it's quite a challenge. And then you have like this parcel here, for example, you have different sort of activities. First, there was a mowing event, which you cannot see at all in the NDVI profile. And then down here, you actually had first a mowing, which you see very clear in the drop. And after that, the farmer put the animals out to graze which was left. So that's why you have a very slow recovery of the NDVI over this long period. So you have 2 mowing events and 1 grazing event. And in the end, what you probably will capture is sort of like the mowing event here. That's probably what you will get in your analysis. And that can be enough for most eligibility conditions. But it just shows that there's a lot going on out there, and it's quite difficult to detect and distinguish. So what we're doing here is that we're trying to use different kind of models, polynomial models, to model over the time series and see if there's a big difference between the model and the actual data, and do sort of a very good guess on, yeah, okay, if it's enough difference, then we would probably say that there was some grazing or some other activity happening, and then it's probably okay. And if we don't see anything and we have enough data, so it's not big cloudy gaps in the data, then we say that, okay, we might need to contact the farmer and see if something happened on the parcel. It's very difficult with the grazing. We've also tested some subparcel detection, and we haven't really done any sophisticated analysis here. We are pretty much looking at the standard deviation over the parcel over the season, and it's just to find sort of the big problems if there's really like 2 different kind of land uses over on the parcel, which might be against eligibility conditions. And so far it looks very promising. I mean, it's a very simple analysis, but it works just fine. So that's another thing we have sort of in the pipeline. Yeah, and some actual results from sort of where we use this in our daily work, and that's in our on-the-spot checks this year. We've done the same last year, and what we're doing is that the first time the controllers are out on the field and they see that, okay, this grassland has not yet been cut or not yet been grazed, they usually need to come later in the season and do another check if the parcel had any activity on it. And in Sweden, you can imagine that it's very long drives for the controllers just to check 1 or 2 parcels on a farm. And we thought, like, okay, here we can actually save some money and some time and do an analysis before they actually go out for the second check and see if we can find clear activities. And that worked really well. I mean, we almost found 60% of the activities. So these 60% we actually saved in field trips. And this one here is areas which were just too small or too tree covered to analyze them at all. So that's almost 19%. And then 15% had such long periods with cloud or cloud covers that we couldn't actually say that no activity happened, because maybe the activity happened when it was cloudy and we couldn't detect it because of that. So we pretty much say we don't know. And then we had around 7% where we had enough data to do an analysis and we could not find any activity. And we have not yet gotten the feedback from the field controls, because obviously we will do a field check on these 7.5%. And so we know if our analysis was right or not. So it's going to be very interesting. But unfortunately, I don't have the data yet. But this is like a very good example on how we can actually save some time and money. And I mean, usually some of these, it's like big fields, and it's clearly that the farmer will do the activity. It's just that the controller was there a bit too early. And it's, I mean, it's stupid to send out the controller one more time to drive a couple of hours just to see, oh yeah, of course he cut grass. So it's good that we can save these trips. Yes, and then sort of what are our next steps? So currently we're not, for all of our own analysis, using actually the data which is in the Sen4CAP and the DIAS. We're still using our API. And that's just to sort of switch the source. It shouldn't be really a big problem, since I mean, the APIs are always quite similar. And we will do some more work, of course, on the pasture analysis. That will probably never stop. And also see that we integrate more the Sentinel-1 data, which we have in the Sen4CAP and our own analysis, because right now we're only using Sentinel-2 data. We'll also collect more ground truth next year, so we can improve our analysis and actually know much better what's happening out there. And as I said, like, we're sort of currently building a system, so it's not just going to be Sen4CAP which does the job, but I mean, we also need sort of, it's a really good toolbox, but it's not that you can just have some Sen4CAP and then you're done. You will probably need some of your own analysis. You need some sort of orchestrator so that things are actually running without you doing manual steps over the season. So we will have our own IT staff to sort of build an actual system around this. Maybe some last thoughts about the Sen4CAP for you who might consider to start with it. It's really neat, and it is true, like, you can sort of start with it right away, and you can put in your in data and it will start running. And it's a bit like, if you don't get any problems, then it's all fine. If you get problems, it's really hard sometimes to sort of figure out what the problem is, especially if you don't like have the time to deep dive into the code and see what's actually the problem. So we're currently getting some help with some of the problems we encountered from CS Romania, and that's been really, really good as well, to sort of give these problems to someone else who can dive into the back-end part and figure things out, and we can focus on getting results. And so that has been really good as well. Since, I mean, Sen4CAP, it will solve some of your problems. It will give you some headache, but it's good if you want to save some time and some steps if you don't have like the people to do these things for you. So that's maybe the main conclusion I'm taking from testing this back. Yeah, that's all I had to say. I think that was also, yeah, the last slide. So thank you very much for listening.
Thank you, Bastian, for an interesting presentation. I'm happy to hear that you are another user with the CREODIAS, with the Sen4CAP that are satisfied with the results. So let's move on to Jan and Jędrzej presentation. Thank you.
Okay. Hello, everybody. Can you hear me? Loud and clear? Hopefully.
Yeah, it's great.
Okay. So welcome, everybody. Today, we want to show you how we are implementing the area monitoring system in Poland. And this is here I would like to also mention my colleague, Jędrzej Bojanowski from the Institute of Geodesy and Cartography, and of course Marcin from CloudFerro. And to start with, I will tell you about the project EOSTAT, funded by the European Space Agency, where we developed the solution for our PAIC agency. And so maybe a few facts about Poland. It's a large agriculture country with more than 15 million hectares, 1.5 million of farmers, and over 10 millions of agriculture parcels to monitor. So for this, you need a huge processing power, which is provided by the CREODIAS. And the beneficiaries of this EOSTAT project was the Statistics Poland, so our statistical office, for whom we developed the crop type classification using Sen4CAP, monitoring of crop growth conditions using low resolution satellite data, and here I mean Sentinel-3, and crop yield forecasting for administrative units. And the second beneficiary was our PAIC agency, where we developed verification of agriculture activities, catch crop detection, and verification of maintenance of vegetation against erosion. And Sen4CAP was our starting point, so we have tested it and we managed to produce all products. Here you can see the in red square our area of interest that we work with. At first, the classification. So the overall accuracy we managed to achieve was 91%, and kappa score 90, 0.9, and we classified 34 crop types. And here on the cumulative plot on the right, you can see the accuracies, and you can see that the first 8, let's say, crop types are classified with accuracy more than 80%. The second product was grassland mowing detection, and here we also managed to run the successfully run the Sen4CAP, and we use all this knowledge, as also Bastian said, to develop our own solution, which looks like this. It's also run on CREODIAS. It's deployed on the virtual machine with Ubuntu 20.04, and as input data we use Sentinel and LPIS. We have some Python scripts. And then we fetch our results to the Postgres database with Postgres extension, which can be easily accessed via API through the web map server, for example, or from the queues. And here we can see our LPIS, the red parcels are the original LPs, and we eroded this original LPs by 15 meters buffer in order to get rid of some problems at the parcel edges. And we also develop our custom green vegetation cover mask. Here you can see on the left the RGB from Sentinel-2. On the right you can see our product, and the yellow it's the no soil or no green vegetation, and the green is of course the vegetation cover. And what we do, we just average out all the pixels within the parcels. So on the top here you can see the field which is fully covered. In the below you can see the field which is just covered by soil, and at the very bottom you have a field where there is a little bit of vegetation cover, a little bit of soil, so our vegetation fraction will be somewhere between the 0 and 100. And this is the exemplar report that we provide to our PAIC agency. So it's kind of a busy graph, so I will tell you what's there. On the left y-axis we have a vegetation fraction. This is the red line. We have the EVI vegetation index, and this is the purple with triangles, and we have the normalized difference water index, and this is the gray octagons. On the right hand side we have the Sentinel-1 data, so we have the backscatter, and here you have to keep in mind that it's not scaled, so this is the native scale, not the decibels, and here you have of course sigma VV and sigma VH polarization. And here, based on this vegetation fraction, we for every parcel which can be analyzed in Poland, we provide the date of greening with some uncertainties. So -14 means that there was 40 days before there was a Sentinel-2 overpass, and +21 means that 21 days later there was also a Sentinel-2 overpass. And here we have also the harvest marked with orange with the same uncertainty estimates. And here in the plot title you can see the ID of the farmer, ID of the field, classified crop, so this is what we get from our classification, and also the declared crop. So here this is the winter wheat, and we can easily see on the graph that it was sown somewhere in the November of 2019, and it was harvested somewhere in July 2020. So it looks like a winter cereal for sure. And we also provide some information about the location of the parcels. So here there's the administrative units, how many pixels there is within the parcel, what is the area, the elongation factor, the inhomogeneity, and also what is the soil type. So here there is another report, and here we can see error. The farmer declared maize, and the classifier said that this is a winter rye. And if I flip forward and backward, hopefully, you can see that, yeah, this looks like the winter cereal, not the maize. Especially that maize should look something like this, so it should be sown somewhere in June and harvest in let's say October or close to October. And here we surely see that it was harvested in July. So with this, the paying agency can provide this report as a justification for not paying the subsidies. We have the QGIS interface for this, where here in colors you can see all the problematic parcels. And we also have the web interface, the geoportal, where you can also look at this reports and make some SQL queries. And additional thing, which is a peculiar thing of Polish agriculture, is the small fields. So You can see on the right-hand side that in Poland, in mountainous regions, we have very, very small parcels, narrow, very elongated, which you cannot process with Sentinel-2 because of the not enough resolution imagery. So here you should go somewhere with around 3 meters. Here you have the special distribution of these small parcels, so you can see that they are mostly in the southern Poland, in the mountainous regions. And for this, we also analyze the Planet Fusion data set, which is the kind of gap-filled product using the machine learning, and it provides you the image, the synthetic image every day. And here you can see the same image with the Sentinel taken by the Sentinel-2 satellite at 10 meters resolution. But currently we also work with CloudFerro for using the Sentinel-2 super resolution product. So here you can see how it looks like at 2.5 meters, which is also enhanced imagery by means of the artificial intelligence. And what we did, we also checked the radiometry of both the Planet and the super resolution product. So here you can see the normalized different vegetation index. On the left hand side you have the results for the Planet Fusion dataset, and here you can see that it correlates well, like 0.96. And on the right hand side you have the super resolution product, which basically equals the standard Sentinel-2 product. So here we can say that there is no difference between spectral difference between the Sentinel-2 super resolution and the original Sentinel-2 image, and this is what to be expected. And we here also check the bands. So here you have the red band, which also correlates well in case of the Planet Fusion data. Near infrared also it's not bad, it's 0.91. But if you go to the green band, here you can see more difference. The correlation goes down to 0.83. And in the end, for an outlook, what we are also trying to implement, it's to downscale or to try to estimate crop yields at the field level. For the time being, as I mentioned, we did it for the administrative units, so for the NATS2 and LAU units. So here you have the crop development differences. For example, this is the forecast for the winter wheat, and this is the forecast for the rapeseed, and we are aiming at doing the same for the individual agriculture fields. So in the end, we provide to our statistical office our forecasts, and here we also analyzed how good we are in the comparison with the estimates or the forecasts that are issued by the statistical office themselves, and we can say that we are on the same level or even a little bit better, but the forecasts issued by our statistical office are based on many experts that works on this, and we provide the fully automated system, which is of course more objective than the subjective personal decisions. And to conclude, we would like to say that we have created the custom area monitoring system for Poland based on experience gained through the Sen4CAP project. Our system uses Sentinel-1 radar and Sentinel-2 optical imageries combined with ancillary information about the administrative units and soil classification. Our system constantly reprocesses data whenever a new Sentinel image is available. So basically, in comparison to Sen4CAP, we are providing the results along the season all the time. The PostGIS database is the heart of our system, which can be easily accessed via GeoPortal, QGIS, WMS, or just an SQL query. Our system generates reports that can be directly used for a justification of the payouts. We optimize and manage the entire system and deliver ready-to-use products for our customers. So basically, our logic is to take the whole burden for the paying agency and to run the analysis and also to optimize our system for the specific regions. Currently, we're adjusting our system to work with the Sentinel-2 super resolution imagery provided by the CREODIAS platform. And to end, I would like to say that we are open for collaboration and for testing the system in different countries. So if you are interested, please contact me or Marcin from CloudFerro. So this, I would like to thank you all for the attention.
Thank you, Jan, for the presentation. I'm very happy that we will try to deliver a complementary solution along with Sen4CAP. And maybe in a little addition to the last point of the Jan presentation, a few words about the development, about the new similar services to the Sen4CAP. Right now, we are trying in a couple of ways implement the new data sets to the Sen4CAP solution. As Jan said, we will try to put the Sentinel-2 resolution enhancer products, which is enhanced Sentinel-2 products from the 10 meters to 2.5. And we will try to implement this to the Sen4CAP algorithm. Also, the second projects include the same service, but with the very high resolution imagery. Of course, in a couple of days, we should see a new release of the Sen4CAP 3.0 image, 3.0 software. So right away after the official release, we will have the image of the 3.0 version also in the CREODIAS public repository in the cloud environment, but also as the solution provided by the Jan and the NJ, it's called, let's say, CAP Toolbox. We will try to implement this also along with the Sen4CAP, like Jan shows us. And of course, I would like to thank everyone for participating in this webinar. A recording will be sent via email and will be placed in the YouTube channel. If you have any question about any of the CREODIAS services, please contact me via email. Also, you can reach us on every social media like Facebook, LinkedIn, and Twitter. Please also visit our YouTube channel and watch our previous webinars related to the Sen4CAP and other CREODIAS and CloudFerro services. Thank you, and I hope that we will meet again on next webinars. Bye-bye.